section 2.6, exercise 14. Alright, well, so I started this already, but then the phone rang and I went to pause it and I stopped it, and I'd done decided that 30 times 30 was 3600, not 900. So, it had major problems. So in 14, we have this balloon, and what we know about spheres, we say a spherical balloon, that the volume is 4/3 pi r cubed. And we're told that the rate of change of the volume is at some constant 800 centimeters cubed per minute. And using the chain rule, since r is a function of t, v is a function, or one way to look at it, v is a function of t, so the radius must be changing because pi isn't changing. So r is a function of t, and so we can also write down that dv dt is equal to 4/3 pi. But then derivative of r cubed, well, that would be 3r squared, but since r is a function of t, we need to multiply by that derivative of r with respect to t, the chain rule. And so we have this. Now the 3's cancel there. And in part A, we're asked for dr dt. Well, when r equals 30 centimeters. Well, so I have 4 pi times 30 squared dr dt is equal to dv dt. But dv dt is 800. And so, if I divide both sides by these constants, well, 800 over 4 is just 200, so I get dr dt is equal to 200 over 900 pi. Now, I got it right that time. 30 times 30 is 900. Now, I can divide 100 out of the top and bottom and get rid of that, so I just get a 2/9, and so we have this is 2 over 9 pi centimeters per minute. Okay, there we go. In part B, the only thing that changes is that now it's r is 60 centimeters. But it appears that the volume is changing at that same rate. And so in this case, we have that 60 squared pi dr dt is equal to 200. So I went ahead and did the 800 divided by 4, because the only thing that changed is the 60 squared, so dr dt is equal to 200. This time I get 3600 pi. Again, I can get rid of some zeros there by taking out 100, but then I have 2 over 36 is the same as 1 over 18, so I get 1 over 18 pi centimeters per minute. And there is number 14.